Okay, cool. Hello, everyone here. I'm Mikhail Egorov. I'm a white hat and bug hunter from Russia. And I'm presenting my talk named AEM Hacker, Approaching Adobe Experience Manager web apps in bug bounty programs. First of all, I want to thank Bugcrowd for organizing LevelUp and giving me an opportunity to present my research here. I do security research and bug hunting. I'm active on Bugcrowd and HackerOne as well, and also have a full-time job as a senior security researcher in a software vendor company. You can find my previous researches on SlideShare and SpeakerDeck. If you want, you can also follow me on the Twitter. Why do I want to talk about Adobe Experience Manager? Participating in bug bounties, I realized that many targets are indeed Adobe Experience Manager web applications. And there are not so many researchers on that topic. I think the main reason for that is because AEM is an enterprise-grade software, and researchers are not able to easily get trial or test installation of AEM to play with. There is just no such an option, and license costs a lot of money. In my case, I was lucky to have a test installation. I should say that AEM is quite complex beast, and many installations are insecure because of uninstalled security updates and various misconfigurations as well. I want to attract attention to AEM web apps in security and motivate bug hunters and security researchers to test security of AEM web apps and maybe discover new vulnerabilities and hacking techniques. In October of 2018, I had similar talk at Activity Conference. Current talk has intersection with the past talk, but they are not the same. I added additional tricks to this talk, and also we'll talk about automation tools I've publicly released not long ago. I want to explicitly mention that all content I'm presenting doesn't contain any ODs. Only known vulnerabilities and techniques are discussed. I divided my talk into two parts: methodology with bug examples and tools for bug hunting automation. Tools are publicly available on GitHub. If you have ideas or techniques and want to share them, you can reach me and I will include them in my tools. Here I included public bug bounty programs known to me that have AEM targets. Also, I included public vulnerability disclosure programs with AEM targets. I suppose some of mentioned companies have private bug bounty programs as well. I want to share my personal achievements from 2018. I reported 84 non-duplicate bugs for AEM targets on Bugcrowd and H1 platforms. The majority of bugs are P1s and P2s. And as a pleasant bonus, I've got 2 CVs from Adobe Product Security Incident Response team. Let's talk about bug categories I found. Among P1s, I found remote code execution and secrets disclosure bugs. Among P2 bugs, internal SRF with high impact, stored XSS, application level denial of service with easy difficulty. Among P3 bugs, internal SRF with medium impact, reflected XSS, application level denial of service with medium difficulty. and flash-based reflected XSS for P4 severity. Here I want to highlight previous works about AEM hacking. I'm sorry if I forgot to mention somebody in the list. Okay, let's discuss shortly basics of AEM and in more details ways to bypass AEM dispatcher. You can see here that AEM is quite complex. It has many layers and the attack surface is quite big. I want to specially outline 3 Apache projects that form the core of AEM. They are Apache Felix, Apache Sling, and Apache OAuth-GCR. Apache Felix is used to manage so-called OSGI bundles. All functionality in AEM is packed inside OSGI bundles. Apache Sling gives a REST API for content repository and also gives the ability to expose servlets from OSGI. Apache OAuth-GCR is a content repository. Everything in AEM is stored as properties for some nodes in GCR. In common AEM deployment scenario, there are 3 main components: author instance, publish instance, and dispatcher. Author instance is placed usually is placed deep inside backnet, and it's not visible from the internet. Content is published on author instance, and through replication mechanisms, content is propagated to publish instances. User normally communicates with publish instance through AEM dispatcher. AEM dispatcher acts as a reverse proxy. There can be additional components sit between user and AEM dispatcher. For example, various different web application firewalls or CDNs like Akamai or Cloudflare. AEM could be deployed on premises or in the cloud, for example, in AWS. We will focus on AEM dispatcher. Physically, AEM dispatcher is a module for web server, Apache or IIS. It filters out requests that don't fit security policy and prevents them from reaching publish instance. In theory, as stated in the official documentation from Adobe, AEM dispatcher is an extra layer in layered AEM security. However, in practice, we see that it's the only security layer. The reality is that AEM admins rely on AEM dispatcher and rarely configure publish instance securely and install security updates in timely fashion. That's very good for us bug hunters. In my arsenal, I have 4 methods to bypass AEM dispatcher. The first one is CV from 2016. It still works quite well today. The second one was discovered by me this year. It allows to access some of the servlets bypassing dispatcher patched for CV. And multiple slashes method works sometimes against weird dispatcher policies. And SRF method might be a universal weapon for dispatcher bypass. Let's start with CV. Here you can see minimal dispatcher policy that was recommended by Adobe before CV. This policy is too restrictive. Usually you extend it by adding rules that allows custom requests. Policy contains rules that are applied sequentially to the incoming request. And what's important, several rules can match the request, but the last rule that matches it is applied. Rule can be of 2 types, deny or allow. If none of the rules match the request, default deny rule is applied that blocks the request. Here you can see the tail of the policy. So here is the bypass. It's stupidly simple. If we try to access query builder JSON servlet on route bin query builder.json, our request will be blocked by the dispatcher. But if we add /a.css to the URL, we can access query builder JSON servlet. Let's return to the policy. If we add /a.css to the URL, request is allowed because of rule 0041. It has allow type, and it's the last rule that matches our request. Of course, Adobe fixed this bug and issued new minimal dispatcher policy. Rule 0041 that should allow access to CSS files now is changed. Now the dispatcher looks for the real extension in the URL and not for the last symbols. And of course, it's make sense. More rules from the policy and the tail of it. Now, if we are trying to access route bin query builder.json or bin query builder.json/acss, the request is blocked because now dispatcher looks for the real extension. I figured out that it's possible to access some servlets, for example, aforementioned query builder JSON servlet, by adding .servlet.some extension to the URL, and the technique bypasses fixed AEM dispatcher. In some cases, we can bypass weirdly configured dispatcher by adding multiple slashes. So if access to /etc JSON is blocked, we can try to access 3 slashes etc .json, and sometimes it magically works. Server-side request forgery in some component on publish instance allows to bypass explicit deny rules of the dispatcher. I found that serif vulnerabilities, which allow to send a GET request and see the response, are quite handy in that case, because you can access GCR with default GET servlet through serif and grab secrets if access controls for GCR nodes is misconfigured. Serif in OpenSocial proxy and reporting services proxy servlet are examples of such vulnerabilities. The next part of the presentation is about automating bug hunting. First tool I built is AEM RC bundle project. RC OSGI bundle allows you to get RC quickly if you have access to Felix console. I included pre-built OSGI bundle for AEM 6.2. It also works in the newer AEM versions. If you find that pre-built OSGI bundle is not suitable for you, or you want to change something in the code, you can generate new skeleton using presented Maven commands, and then backport backdoor servlet class from my project to the newly created skeleton project. There is a separate command line for AEM version 5.6. For all other AEM versions, you have one command line. You should select archetype version correctly from the table presented on the slide. Bundle includes a Sling servlet on path bin backdoor.html. Servlet has parameter cmd that accepts shell command to execute. Another project is AEM Hacker Toolset. It includes several scripts written in Python. The main tool is AEM hacker.py. It scans AEM target for known vulnerabilities and misconfiguration. It implements AEM dispatcher bypass techniques I've described earlier. In order to detect server-side request forgery issues, you should run the tool from your VPS. And you need to do extra work to get something exploitable out of tool output. For example, it can detect slim post-servlet availability, and to get an XSS, you should find a node in GCR that allows anonymous modification or gets credentials with some level of access. Here is the help message for the tool. It supports multiple workers, threads, and ability to specify proxy for all requests. With host parameter, you specify IP address or host name of your VPS. This is required for SRF detection. Parameter port allows you to specify a port number on your VPS for back connections. Default port number is 80. Commonly used command line is presented here. Currently, AEM Hacker implements 22 unique checks. They are listed on next 3 slides. The next tool is AEM Discover. It takes list of URLs and detects AEM web apps among them. Tool implements logic to bypass AEM dispatcher. Commonly used command line is presented on the slide. With parameter workers, you can specify the number of parallel workers. Some numbers about the performance of the tool. It took 2 days to scan list of 500,000 URLs using 150 workers. Help message for AEM Discover. The next tool is AEM Enum. It traverses GCR using default get servlet. It sniffs out usernames and secrets. Here is the help message for the tool. With parameter base, you can specify node to start traversing from. If you omit this parameter, node is selected automatically. With parameter grab depth, you can specify depth of the subtree that is fetched in each iteration. It affects speed of the tool, but you can specify arbitrary large values. If value is too large, AEM returns HTTP 300 response without actual data. Parameter max depth specify grabbing depths. By increasing this parameter, you can get more data, but it will take more time. Tool outputs results in CSV format. Here you can see commonly used command lines. First one is good for grabbing usernames, and second one is good for grabbing secrets. The next pair of tools, tools AEM SRF2RC and AEM Server. They help to exploit SRF in site catalyst servlet and auto provisioning servlet as remote code execution. But there are 2 prerequisites. AEM version should be specific. I tested it on AEM 6.2. And if CFP7 is not installed, exploit chain works perfectly. Another requirement, application server should allow HTTP smuggling. Jetty is the default application server for AEM, and it supports HTTP smuggling. To get RC, we exploit reverse replication mechanism after joining AEM topology through SRF. Here is the help message for AEM SRF to RC2. First, you should run AEM server script on your VPS. It mimics reverse replication process by serving file response.bin. To start the attack, you launch AEM SRF2RC script. In URL parameter, you specify paths to access site catalyst servlet or auto provisioning servlet. In fake AEM parameter, you specify host name or IP address of your VPS, where AEM server script is running. And if RC is possible, you should see incoming connection to your fake AEM server. Then you can access the shell using paths presented on the slide. The last tool is handy when you have credentials of privileged user, but don't have access to Felix console of AEM. It works by uploading GSP shell to apps node. The rest of the slides will be devoted to methodology. Usually people install additional bundles and packages on AEM. Some packages include frameworks used by applications running on top of AEM. Others include additional consoles or fiddles that is the administration. Some of them might be insecure and allow attacker to completely compromise AEM. The first example is Groovy console. It allows to execute arbitrary Groovy scripts on AEM. The problem is that it doesn't have any authentication. If you can bypass AEM dispatcher and access servlet that Groovy console exposes, you can run arbitrary code on AEM. I have doubts that this bundle is intended for production environment. However, I quite often see it on popular sites. Servlet is located at the following paths. And here's an example from bug bounty program. I was able to execute arbitrary shell commands by sending post requests without any authentication. The second example is ACS AEM Tools bundle. It exposes fiddle that allows to execute scripts of different formats, including GSP. It may or may not require authentication. Here is the example of how you can execute GSP scripts using a fiddle. Now let's observe what can you do with different levels of access to AEM. If you have credentials for some user, you can get RC or completely deface site or get persistent XSS. It depends on access level you have. How can you get the credentials? In AEM, there are built-in users with default credentials. Admin and author are two of them. Sometimes you can find AEM webapps where those credentials are not changed. You can also try to guess the credentials via brute force attack. Luckily for us, AEM supports authorization without brute force protection. You can easily grab valid usernames from properties of GCR nodes. Nodes usually have such properties as GCR created by, GCR last modified by, that contain usernames. If you have credentials of a privileged user, you can get RC. There are several possibilities for it. If you have access to Felix console, you can upload OSJ bundle and get RC. Here is the example from Adobe VDP. First, using login status servlet, I checked that admin credentials are valid. Then I specified match and replace rules for burp. I did it just for convenience. First rule adds authorization header to the requests. And the second rule is for AEM dispatch and bypass. On the third step, I uploaded OSGI bundle by accessing PAS system console bundles. The other possibility is to use Sling scripting when Felix console is not accessible. You should create child node of apps node and upload GSP script to it. There are several options to do it. You can use Sling post servlet for that case, and my script AEM RC Sling script.sh from AEM Hacker toolset automates this process. If WebDAV is enabled in AEM, you can do that stuff using WebDAV. If you have access as author user, you can create new content, modify or delete existing. You can completely deface the site. Author is a privileged user. You can manipulate content with Sling post servlet, or you can manipulate content through WebDAV if WebDAV is enabled. Or, for example, you can use CRX D-Lite console. That should be available at PAS CRX dindex.gsp. With credentials of non-privileged user, you can try to find using query builder servlets what nodes are accessible to you for writing. There is special predicate with name has permission for that purpose. After finding a suitable node, you can try to modify existing or create new content to get an XSS. With anonymous user access, you similarly can try to find nodes in GCR for which you can add child nodes or has GCR write permission. Usually, anonymous user has GCR add child node permission for content user-generated node, and GCR write permission for content user-generated at C-commerce SmartLeads node. Here I want to share several tricks how to get persistent XSS when you have write access to some GCR node. The first one assumes that you upload SVG image with JavaScript inside property value of a node. It's quite widespread among AEM web apps that when you, for example, add /a.svg to the URL, content type of the response is changed to image SVG plus XML. The second trick assumes that you create property with name aaa.html and HTML inside property value. Third trick utilizes ability of Sling post servlet to upload the file and specify MIME type of the file. Let's observe examples for each trick I discussed. Here is the example from Twitter bug bounty. I found AEM on Twitter.com subdomain with accessible post servlet. And due to strict CSP, I needed to stage XSS payload. On the first step, I uploaded JavaScript. On the second step, I uploaded an SVG file that referenced JavaScript from step 1. Later, when I accessed property of GCR node, I had an XSS. Note that I added /a.svg to the URL and as a result, content type of the response was changed to image SVG plus XML. Next example illustrates second trick. Now I add property with name aaa.html and value containing HTML. Now when I access property, I have an XSS. The third trick, I created a new node with name XSS and specified HTML content in GCR data parameter and text HTML in GCR MIME type parameter in post request. When I tried to observe new node, alert box appeared, and we have XSS. Leaking secrets from GCR. Everything in AEM is stored in the content repository that represents a tree structure starting from GCR root node. This rule also valid for various secrets, including passwords for databases or online services, encryption keys, secret tokens, production configuration backups, private information about users like emails, home addresses, and so on. Why is it possible to leak secrets? Because admins rely on AEM dispatcher and don't configure access controls in a content repository. For data exfiltration, we can use built-in AEM servlets like default get servlet, query builder JSON servlet, query builder feed servlet, GQL search servlet, and others. Default get servlet allows to get GCR node with its properties. It supports various selectors and data formats for convenience. Selector tidy allows to get formatted output. Selector infinity allows to get in one request properties of the current GCR node and all its children. Instead of infinity, we can use a numeric value that determines the depth. -1 is equivalent to infinity. And the format res allows to retrieve files that are normally stored inside GCR data property. For example, when we are accessing route/.tidy.3.json, we are getting formatted JSON that contains nodes and their properties starting from GCR root node with depth 3. You can use following approach for data exfiltration. On the first step, you get information about direct children of GCR root. However, in some cases, listing for GCR root is prohibited. If so, you can try to guess node names. Common node names are content, whom, var, etc. And on the second step, you can start traverse GCR and dump node properties. When depth selector is allowed, you can get GCR subtree using one GET request. Some common places to look into. Children nodes of etc usually contain various secrets, database connection, strings with passwords, encryption keys, and secret tokens. Children nodes of apps system config and apps something config usually contain passwords. Children nodes of var node may contain private information of users, and children nodes of whom node contain AEM users profiles with private information and hashed passwords. Normally, properties like GCR created by, GCR last modified by, of any node contain login names of AEM users. Here is the example from bug bounty program. It was possible to pull database connection string and database password in clear text without authentication. This information was stored in child nodes of apps redacted config node. I bypassed AEM dispatcher by just appending /a.ico to the URL. Here is another example with default get servlet. I was able to get private key from configuration for Puppet module by navigating to this long URL marked red. Query Builder JSON servlet and Query Builder feed servlet allow to search things in GCR using various predicates. A link shown on the slide describes all supported predicates in details. Query Builder JSON servlet returns information about GCR nodes and their properties. Query Builder feed servlet returns information about GCR nodes, but no properties. But never mind, in some cases we can retrieve node properties through blind binary search. On this slide, I collected searches that often rescue me and give me security bugs. Let's proceed with examples. This search gave me a path to zip archive with production configuration of AEM instances. I was able to download this archive, and configuration from archive included passwords for various network services. This search gave me access to AEM users' profiles with SAML tokens and hashed passwords. This search allowed me to get database connection strings with passwords in clear text. Last example, with has permission predicate, I was able to figure out what GCR nodes were writable by anonymous user. Later, I was able to upload HTML file and got persistent XSS. Let's look at server-side request forgery vulnerabilities and their exploitation in AEM. Details of SRF vulnerability in OpenSocial Shindig proxy have been publicly known for several years. You can find blog posts by Peter Atkins from 2016 that mention this vulnerability. It allows to send GET requests to an arbitrary URL and see full response. It's suitable for exfiltrating secrets from internal network services, for example, from metadata service in AWS. It also allows to bypass AEM dispatcher and perform secrets exfiltration using default GET servlet or Query Builder servlets. And at the very least, we can exploit SRF as reflected XSS that allows to bypass XSS filters in browsers. Here is the example from bug bounty program. By exploiting server-side request forgery in OpenSocial proxy, I was able to access network service on localhost port 8080 that allowed me to read local files. On the screenshot, I demonstrated how I was able to read error log. SRF in reporting services proxy servlet is similar to what we have discussed previously. I discovered this vulnerability in 2018 and Adobe assigned CV ID for it. It allows to send GET requests to an arbitrary URL and see the full response. Here is an example from bug bounty program. I was able to read AEM role credentials from metadata service. Another example shows how to bypass AEM dispatcher and exfiltrate secrets using default get servlet. Here, AEM publish instance is running on localhost port 4503. This SRF was found by me as well. Adobe assigned CVID for it. With SRF in Salesforce Secret Servlet, we can send post requests to an arbitrary URL and see the full response. If internal network service does not differentiate between post and get requests, we are able to exfiltrate secrets from such services. And this is true for metadata services in cloud providers. And of course, at very least, we can exploit the SRF as this. Here is the example from Adobe VDP. I was able to get credentials for AEM role using SRF. And an example where I exploited SRF as XSS. SRF inside Catalyst Servlet allows to send post requests without seeing the response to an arbitrary URL. But we can send arbitrary headers in HTTP request using CRLF or CR injection. When specific AEM version and application server are used, we can achieve remote code execution from SRF. We can see that vulnerable parameter is data center. Through CRLF injection in username parameter, we can send arbitrary headers in the request. SRF in auto-provision servlet is similar to SRF inside Catalyst servlet. But there is a little difference. With auto-provisioning servlet, we should send post request instead of get to trigger SRF. Vulnerable parameter is analytics.server. Through CRLF injection in analytics.username parameter, we can send arbitrary headers in the request. I was able to escalate SRF to RC in AEM 6.2. It stopped to work when I installed CFP7 fix pack. Exploitation also requires Jetty application server, but it's a default option for AEM. You can use tools from AEM hacker toolset to check if it's possible. Let's see how it works in action. So first I'm checking that RC node does not exist in GCR. It doesn't exist. Next, I'm running a tail command to see the requests in access log. Now I navigate to this long URL. And in access log, we see that put request to topology connector was successful. Now we can launch AEM server and wait for connections from our target. We see the connection, reverse replication process kicks in, and we should see that RC node in GCR was created by reverse replication agent. It was created, and we can access our shell now. Yeah, it works. Some old tricks, they can be relevant today if you find suddenly old AEM version. One of them is Java deserialization bug in external job post servlet. Servlet takes file parameter from HTTP request and passes it to object input stream, read object call. And we have classical Java deserialization issue. Here we generate deserialization payload that should consume all the memory space in Java heap. We send our payload and see the error that tell us that there is a problem with Java heap failure to allocate required memory. Another thing is XXE, XML external entity vulnerability in WebDAV implementation I discovered back in 2015. You can exploit it using prop find prop patch technique. You can quickly spot if WebDAV is enabled by sending options request or making get request to pass CRX repository request. Let's explore several cases for reflected XSS vulnerabilities in AEM. There are several XSSs in SVF files. They were reported by Franz Rosen. VCM debug filter had an XSS vulnerability previously. Additionally, plenty of built-in servlets in AEM return unescaped HTML from users' input in JSON response. And you can get reflected XSS. For example, suggestion handler servlet is suitable for that. It takes parameter with name prayer and returns its content back in JSON structure without escaping. Sometimes you can manipulate the content type header of the response by adding, for example, /a.html to the path in the URL. Let's observe examples. Here you can see Flash-based XSS in a video player.svf file. Here you can see example of XSS via vulnerable VCM debug filter. And finally, example with suggestion handler servlet, adding /a.html to the path forces AEM or some proxies to change content type to text HTML, and we have an XSS. Application level denial of service attacks are quite easy to implement against AEM web applications. You can create notable load on AEM instance by submitting these simple requests. And some programs luckily accept application level denial of service submissions. Let's look at example. It's in response to this simple GET request, I received big JSON 700 megabytes. It took 6 minutes from the server to return the response. And I want to mention that this JSON is not a static file. It's generated on the fly by X3 servlet in AEM. And in conclusion, I'd like to say that AEM target is a gold mine for a bug hunter. I hope my research will be helpful for the bug hunting community. And one more time, I want to say thank you to Bugcrowd for organizing this wonderful event. Thank you.